Engineer, please, you have the floor.
Hello, good evening, everyone.
Good evening.
Okay, so I want to welcome each and everyone here for today's webinar. My name is Patricia, and I'm speaking on behalf of Engineer Benedict Atapoku. Okay, so today's webinar, I believe, is going to be a great one. Most of us here are students, and even if we are not students, we are also into research and then also in the industry as well. So I believe that the topic is going to delve deeply into how we are going to translate our research, especially those of us who find ourselves in the industry. So I'm hoping that we have a good time, which I believe we are going to have. And then I also want to welcome the speaker and have him start his presentation right away after the MC has introduced him. Thank you very much for your time. Welcome once again. Thank you. Over to you, Mr. MC.
Okay, thank you so much, Engineer Patricia Anko. I just believe I got the surname right. If I didn't, please pardon me. So we'll move straight ahead. Okay, thank you so much. The presentation would be just a 30 minutes conversation, like we always do. We would not want to spend too much time here. In 30 minutes, the presenter is done, and then we can go ahead with the Q&A session. So please, like I said, you do all to pay attention, note down the points, and where you still have you still want to get a bit of clarity, you do all to ask your questions. That opportunity will be given. So we'll move straight ahead. Our speaker for the day is a senior professional engineer with the Ghana Institution of Engineering, GHI. He serves as the vice chair of the Obuasi chapter and is a member of the Education and Training Committee. With over 12 years of engineering experience in mining and process automation, he currently leads the communications, instrumentation, and controls function at a major gold mining operation in Ghana. David is a certified Six Sigma belt with academic qualifications in both electrical and electronics engineering and strategic management. His career spans practical system automation, plant optimization, and cross-functional leadership. What sets David apart is his drive to bridge the gap between classroom theory and plant floor realities. He is deeply involved in mentorship and capacity building initiatives, helping young professionals translate research ideas into actionable solutions that meet industry needs. Ladies and gentlemen, our speaker for the day is no other person than Engineer David Arthur. Engineer, please, you have the floor. 30 minutes for you. Kindly do us the honor. Thank you so much.
Okay, thank you very much, team. And it's a great honor that you've given me to have the opportunity to talk to all of us here on the topic that I think worries all of us. And I don't know, please, MC, can you confirm if you can hear me?
Yes, we can hear you loud and clear,
okay,
sir.
That's perfect. All right. So you mentioned that the presentation is going to take 30 minutes. Yes, possibly or less. And it's better we do more of the talking rather. So that is how I've structured it. It's going to be very conversational. And as the MC rightly mentioned, I'll entreat all of us. I know we all have ideas on how we can bridge this industry gap, industry and academia gap. But I have been given the opportunity to lead a discussion today. So I am presenting my perspective. I know a lot of the team members also will have their own perspective, and it is on this forum that we can have these discussions and we can feed this into policies going forward to help all of us, if not all of us here, maybe the next generation of engineers that will be coming out of the various campuses that we have for engineering. So our discussion to start with is going to be centered around translating the research into industry impact through collaboration. If you are all aware, the bridging this gap between the academia and the industry is much needed in Ghana. This has been done in a lot of countries that we call developing, and unfortunately for us, we are left behind. And this is very important for us to consider as a country because this forms the foundation of modern economies. Research and innovations are essential for driving the economic development today, and it is very important that we as a country also take this. Also, Ghana produces a lot of academic outputs. I think it was the MC that rightly mentioned, when you go to the libraries of our institutions, you have a lot of research materials that are rotten away, and we don't have any use of it. Yet many of these innovations, they remain unpublished, or if they are published, they are underutilized. Also, there is a disconnect between the research and industrial applications, and this hinders the economic growth and competitiveness of our industries. We have a lot of research, but these research are based on something that at the moment our industries might not have any use of them. So in that case, the research comes out, but then nobody needs the research at the moment here. We have to have a strong collaboration between academia and industry, and this can transform research into practical solutions that will lead to the industrial advancement or industrial revolution that we always talk about. Also, these gap, when we are able to bridge them, will lead to more economic and technological disruptions. We can be able to be better prepared for these changes as they are inevitable in the industries. Still to mention, Ghana, unfortunately for us, we are more dependent on our natural resources, be it mining of all kinds of ore in Ghana, and also oil and gas and agriculture. Now, making it essential for us to innovate, be innovative in these sectors so that we can be able to scale up and work smart in all these industries, be able to increase our output from these natural resources that we have. Unfortunately, the presentation will lean more towards mining because that is the industry I have worked most longer in, and I have much practical experience. So it cuts across all the industries, but I'll be talking about mining a lot more. So there are a lot of challenges, for example, in the mining industry, which I know happens in all the other industries that need practical solutions. And we need the academia to come form hand in hand with us for us to be able to solve these issues. Also, we talk about the research. Sorry. Yeah. Okay. We talk about research and industrial collaboration. While the universities produce these valuable research, there is often lack of the platforms, and this GHIE does very well with it, especially if we go to our conferences. There is a platform that these institutions, these schools are able to present their research materials, but are we linking it well with the industries for them to know and be able to do the proper testing on the industrial level to be able to commercialize it? Also, we have to build local capacity, and these effective partnerships will be able to reduce the reliance on imported solutions. We don't only import materials externally, we also sometimes import solutions, and if we had tested some of these things here, we'll be able to have solutions that are suited to our environment. Now, this academia and industry collaboration also leads to sustainable development. And the first one, it benefits the industry. They have access to innovations industry-specific solutions that will be in the graduate pipeline. So all the solutions can be timed in a way that every year we have some solutions coming out. So it doesn't benefit only the academia, the industry is the first hand in here. The academia also benefits from this in the sense that they will have access to real world data to be able to test different modules, different systems, different equations that has been theorized in the institutions. So you have real world data to be able to test. And also the academia will also have funding opportunities. Definitely, if you take a company and you're doing a research for them about a problem they are having, definitely they are going to fund it. We get money, not only from the government, but from these institutions to be able to fund different projects in the institution. Also, once these things continue, we would have the opportunity also of improving the curricula of these institutions. If you go to some of the universities, unfortunately, some might have curriculum for the engineering sectors that maybe we don't even remember the last time that they were revised. Some are very good in revising these curriculum from time to time. But what is the industry inputs into this curriculum? So if there is this synergy between the academia and the industry, you see that time and time again, the students that are coming out will be coming out knowing actually what is happening on the field, and there will not be that disconnect. Also, there will be benefits to the country as a whole, as we have already mentioned. We'll be aligning research to the country's priorities, right? And also promoting innovation. Then that will lead to sustainable development or sustainable growth for all of us. I'll just be giving some examples, especially in the mining industry, as I earlier on mentioned. One of them is a challenge that we have in refractory ore that have dynamics that standard processes of metallurgy are not able to recover the gold or whichever raw material, the ore that we need. And therefore, research needs to go into the different strategies that we need to be able to either increase the recovery rate or find any other strategies that we can use to liberate these ore from the ore body itself. So there is an academic research opportunities in situations like this, where the metallurgical engineering department for the various institutions undertake research into innovative solutions like the flotation reagent, bioleaching, or biological oxidation, as some areas are using it, and other methods that can be able to generate an ultra fine grinding to tackle the challenges with the refractory or the ore variability issues that we have in the industries. Also, this industry collaboration, these partnerships can facilitate. Yes, the institution is doing the research. The company will have a system that we can do some pilot testing, for example, that will test these new methods that the institutions have developed in actual processing plants, so that we can use industrial grade equipment to test the theories in the classroom. There is also a focus on the tailings management. All the mining companies that we have around, they generate waste, right? These wastes are toxic to the environment, and there are ways that EPA collaborates with the companies to ensure that we are safely handling it. Can we research into various ways of detoxifying these wastes? There are studies that is going on some even bacteria that can be able to digest cyanide, for example. What are our industry or our institutions in the country doing to be able to help bridge this gap and be able to mitigate these environmental liabilities that we have? Because in as much as the companies are taking the raw materials away, we are left with these legacy waste that will have long-term environmental impact. So whatever it is, we have to find solutions to them. Some are resorting to even retreating the tailings materials, which is very good. Also, all these will lead to point 5, a very positive industry impact. So successful implementation of these research methods leads to higher gold recovery rate. And currently, if you look at the throughput for some of the companies that we have around, even a research that can lead to a 1% increase in gold recovery rate is a lot of money. You are talking about 10 million, $20 million thereabout per year. So it is very lucrative that if we are able to invest in it, it will help both the academia and the industries. Now, if you come to my training, that is, I'm an electrical engineer, so we talk about power quality challenges in electrical engineering. We all know all around us, one of the biggest challenges of the various industries is the unreliable power quality. We constantly have power dips, power surges, and all that. The academia have the opportunity to have research solutions into how we can even mitigate these harmonics that is on our system, how we can predict the failure of the major distribution network systems to ensure that we are able to predict these failures and be able to get solutions to them before they lead to bigger problems and so on. And even integrating renewable solutions into the energy mix. Also, some students can take on some capstone projects, which involves engaging in this capstone project in the focus on mine-wide power optimization, energy efficiency. All these companies we have around, we have the energy management section. They have all the tools that maybe the educational institutions might not have. During this collaborative effort, we can be able to use these tools that is available to be able to test the system and generate, bridge this theory and practice gap. Also, cost reduction here. Once we are doing all these, sorry, I skipped the point 5. The impact of all this is to have an improved equipment lifespan. Nobody wants to be buying transformer every year or replacing transformer even every 5 years. If we are able to have a predictive maintenance approach into these equipment, be able to take out harmonics that result to extra heating and all that and the losses in the system, you are able to have an improved lifespan of the equipment that this industry use. And overall, it all comes back into money, that we make a lot of savings out of these. Now, another example I'm throwing out there is enhancing thickener performances. All mining companies use thickeners, and thickener, the function of the thickener is to add some flow coolant. Based on the densities, you pump the underflow, and the overflow is what you more like a clean water that you can reuse and all that. But over and over again, if the thickener is not performing well, you will either be overdosing, wasting money or flow coolant, or you'll be silting your storage tanks because you are not dosing well. There is high turbidity, and this forms the sludge under the tanks. Can we go into systems that we can be able to use AI algorithms to be able to drive the dosing of these flow coolants? So in that case, you pick the parameters, whether it is the pH, whether it is the turbidity, whether it's the densities, you put all of them together and you can be able to predict how much that we should dose into the system. All these are possibilities, and there are real life simulation opportunities because the plants currently are operating these equipment already, and it will help the institutions to validate the effectiveness of the proposed dosing strategies that we have given. Partnering with this industry also allows for every sensor data to facilitate prototypes. If it is a PLC or SCADA system, it's already available in the industry. So you are able to ensure the practicality and the applicability of the research outcomes. When we implement these, it will lead to an increased process stability, enhance reagent dosing efficiency, and reduce operational cost, and as I indicated, improved water recovery from the thickener. Now, these are all examples, and this last one has to do with the control system reliability, also through collaboration with these institutions. So not to talk a lot on these, but all these are avenues that the various institutions can delve into. But you see, if we are forming a partnership, and each of the partners in the partnership is sitting in a silo, then it creates the issue that, yes, the industries have a lot of problems, but then the educational institutions don't know what these problems are. And because of that, the educational institutions, not that they are not doing research, they are doing a lot of research, but then the research don't talk to the pain points of the industries. And that is why these platforms that we are having is necessary for us to understand that these avenues are available. You just have to talk to the right people in the industry, and the people in the industry should also talk to the right people in the academia to ensure that, yes, the pain points that we have, the research is ongoing about them, but the research is directly impacting on the solutions that we need for the problems that we have. Now, one way we can bridge this gap, in my own thought, as I said earlier on, is that we have to, as the industry, be able to accept the internship opportunities, for open internship opportunities for the students, all right, to come into our industries, to have these industrial attachment programs, which helps the student to actually know what is really on the ground. And it's very surprising that some of the students come on internship and maybe they've been taught about electromagnetic theorems, industrial AC motors, and it is only when they come out that they are seeing for the first time an industrial AC motor of the sizes that actually we have in the industries, right? And most of them, once they have people taking them through these systems, when they come out, they are able to now, especially if they are in the second year, third year, thereabouts, they are able to plan around on their project that they are going to do in the final year. They are going to plan around it better to get a better project topic that they can actually have an impact on it for the industry. Also, we can have a joint research grants that take key industrial challenges. So this goes above what we have for the internship, but this, we have a problem. The companies give grants to the institutions, and these grants directly are supposed to channel the research into the problems that these industries are facing. So this focuses on the main pain points, like what I mentioned earlier, the all variability that we are having. And this all variability issue doesn't run through only one mine. Across the country, a lot of mines have these issues. Also, there has been a lot of challenges, especially with respect to lecturing roles in the industry. You have a lot of people in the industry, sometimes with 20 years, 30 years experience. And the things they are able to explain to you, sometimes you marvel, right? But these people, unfortunately, maybe because they don't have their masters, for example, cannot lecture in the universities because of how the whole educational institution, their system is structured. But can we have an arrangement that, yes, maybe the person doesn't want to become a lecturer permanently, but we can have guest lecturer arrangements where people experienced in specific fields in the industry will be paired up by, I don't know whether maybe like GHIE or other institutions, to ensure that, yes, I am teaching electromagnetic theorem or I'm teaching instrumentation, and when it gets to the practical part, or maybe 2 weeks after I am done with my lectures, 2 weeks before we have exam, an industry personnel who is very experienced in it will come over and come and take the students through the practicality, what is actually happening on the field. That will help bridge this gap much further. Also, yes, sometimes GHIE, we have our conferences, but one thing that I think we can introduce in some of these conferences is this hackathons and innovation challenges that will be able to stimulate problem-solving skills for those in the university. I know Ghana Gas, for example, have some quizzes for all the universities, which is a good thing. But can we also introduce practical projects, maybe led by something like an institution like, say, Ghana Chamber of Mines? They have this an institution for all the mining companies in Ghana, right? So we pick a topic or a challenge that is peculiar to all the companies in the country. Then we give it out as a challenge to the institutions for it to be competitive. Then we will see the innovations that will come out of it. And we'll be able to test some of these in the industries. And the ones that work for us, we can be able to properly implement it. Now, in these, all of us have roles that we play in this. And when I say all of us, I'm saying the universities, the industry, and the government. We all have roles in this. The universities need to establish advisory boards that aligns research topics, foster student engagement, and also promote knowledge transfer between the universities and the academia. The industry also have some contributions they can make. That is providing funding, providing mentorship opportunities, also access to facilities and engaging in collaborative projects. There are a lot of barriers, for example, that if an institution or a student want to come and maybe access the lab equipment for an institution, maybe you would have to write letters. It takes a lot of bureaucratic steps before the student can be able to have that opportunity. If we are able to bring down some of those barriers, at least, it will ensure that, yes, we are opening our doors for the research team to also join us in the industry. And also these mentorship opportunities, we have in our company an arrangement where national service personnel and the graduate trainees are paired with experienced engineers in the company, and we have one-on-one engagement with the team. This is very important in building the experience. But then I think we need to explore further, not only when the person has completed university and he's doing their national service, but then is it possible for us to even explore further into those who are already in school, so that we can have that guidance with them to be able to shape their thoughts even before they come out. The government also can provide some tax incentives to companies that actually hire or provide these arrangements for the institutions to ensure that they are doing more of it. They can also provide some seed funding, also some regulatory frameworks to promote this public-private partnership. And all these will ensure that these institutions are doing it and doing it very well. Professional bodies like us, GHIE, and then they translate into young engineers, we also have a function that we play in here. We have to facilitate this collaboration. We, as a body, have both the academia and the industry all in our group. So we are better positioned to ensure that we are facilitating this collaboration. Chamber of Mines used to have an arrangement where some students were paired with some mining companies, either through scholarships or so that every time they need to do internship, they go to particular companies. That can be done with GHIE in the industry to ensure that students, engineering students, are paired, or maybe institutions even are paired with some companies to ensure that, yes, we are translating this research into actual results on the field. Also, during conferences, there are definitely some success stories. When we are able to share these success stories on the platforms that we have, it is able to motivate other people to also take that step. Maybe they might have some fears. It helps them to also take that steps. And also organizing network events that builds, that bridges the academia to the industry. Now, when we are able to do this, it's it has direct impact on the industry. It translating the research for socioeconomic transformation of the country, the mining processes, or for industry innovation, testing and scaling also. And we have this tripartite partnership between the academia, the industry, and the government. And when we are able to achieve this, we get to have a robust ecosystem between the professional bodies, the educational institutions, the industry, and the government. And therefore, across all levels, all the policies that we'll be talking about will have proper pipeline that will be able to execute all of them. Now, we will invite all stakeholders, and the stakeholders, as I indicated, is all of us, to ensure that we are inviting people for collaboration, engaging the proper stakeholders at every level of opportunity that we have. We should engage the stakeholder, being academia and government, to work together to provide this synergistic environment and also create effective frameworks that can facilitate and support this industrial initiative. We can also focus on innovation, which its primary aim is to address the unique challenges that has been indicated early on. Now, this brings me to the end of the presentation. I know there is a lot out there that we would want to talk about, and want all of us to come together, think together to ensure that whichever corner that you find yourself, do the very little that you have. If there is an opportunity for you to go back to where your former institution, for example, to offer the support that they need. There are lots of the educational institutions now that when you can contact them and provide input into the curriculum, for example, if you can find some student to be able to mentor. As we haven't gotten to this level yet, let's all, wherever we sit, do all we can to support these young engineers that we have at our sections. When you have national service people come to your sections, when you have graduate trainees at your sections, spend time with them, make it conscious effort that you are engaging with them. Not as we see in some industries where national service personnel are used as they are the ones cleaning the here and there. We are sending them to buy as cocoa and nkate along the roadside, buying wache here and there. Let's give them proper challenges. And when the interns also come from the school in their short vacation periods, please, let's ensure that we are establishing proper contacts that doesn't only end at the time that they are done with their internship, but we can constantly be engaging them even when they are back in school and providing them with the necessary support that they need. When we do that, then I think, even though I say that we are not yet to the level that we want to get to, we all will be contributing the very little that we can to support this ecosystem that we are trying to promote. Thank you very much for indulging me. And at this point, I'll leave the platform for the MC if there are any questions and contributions. Thank you.
Thank you so much, Engineer David Arthur. I must say that you were very brief and right on time. And then also your lecture, as it were, was very clear and understandable, and very understandable, I mean. So we are grateful to you for the very brief and intensive presentation you have done. Like I said earlier, we'll be given the opportunity to ask questions and then even make contributions where possible. We've basically had conversations around benefits of academia, industry collaboration for sustainable development. He also spoke about innovative solutions in the mining and metallurgy industry. He spoke about oil recovery, tailings, and the likes. He also said something about how the power quality challenges in electrical engineering, for example, can be addressed. He gave us a practical example about how we can enhance thickener performance through AI control systems. And he moved on to have conversations, to discuss how best we can enhance collaboration and to bridge the gap between academia and industry. And in there, he said something about internship and attachment opportunities. He said something about joint research grants. He had conversations around the need for us to have guest lecturers in our universities, not necessarily people who have MPhils or, if you want, doctorate degrees, but I mean, poaching those who have been in the industry for a very long time, irrespective of their academic backgrounds, to impact the knowledge that they've been able to gather throughout their years of service. And then also propose that hackathon and innovation challenges should also be organized more, so that people can be able to practicalize their ideas. And then he said something about how best we can collaborate. He said something about collaborative rules of universities, industry, and the government in research. And so we'll jump quickly into the questions. I can see the first question in the comment section. For those of you who would not want to speak, you can just leave your question in the comment section. I'll read it wide, and then the presenter will do justice to it. So I can see Lordina Men. She says, how do we identify a problem from the industry that can be translated into industrial applications? Because I remember when you were sent, when you are sent for an internship, your lecturers advise you to find a problem for your final project work, but it is hard to find one. The industry seemed fine. And so say, I don't know if you get Lordina Men's question. Maybe you can do justice to it.
Get Lordina's question. So I think the problems there are a lot around. There is no industry, I think, that is perfect yet. There are always ways that we can optimize our processes. But two things here. The challenge might be there are some companies that are open for growth. In the company I work in, one of the values that we cherish is the continuous improvement, right? So the system can never be perfect. So there is always a better way of doing it. So for example, we have our the graduate trainees taking on projects every year, and we have something they do every year. But you see, sometimes the time for the internship might be short, too short that maybe you don't have enough time to ask the right people. That is what I think might be one of the challenges. And also, those of us, the engineers, I know we are all young engineers on here, but some of us are already in the industry. I also think most of us don't spend much time with the interns when they come around, which is very sad, because the guys coming in, we can only train them up to our level if we spend time with them, sharing the various challenges that we have with them. Until that point, I think we will not be able to find any headway. So, Lordina, I think that, yes, what you're saying is true, but we all have the opportunity now. We are at various sectors in the industry. You will have an opportunity for an intern to come to your end. Please spend time with them, assess them. Some of the questions they might be asking, if you've been on the field for a while, you might think that it's non-far, right? But reshape their questions for them to shape their thinking. They might have a lot of the theories, but don't even understand the practicals on the field. So if we shape them rightly and we don't actually just condemn what they are saying as in, no, this is not possible, no, this is not possible, we can actually reshape what they bring out better, and it can actually lead to a proper project out of that. Thank you.
Thank you so much, Engineer Arthur. Please, if like I indicated in the chat box, if you have a question, you can use the gestures, the hand gesture. You can raise your hand, then the host can be able to allow you in to ask your question once your name is mentioned. If you want to go by the option of leaving your question or contribution in the chat box too, you can actually do that. In the meantime, I'm not seeing any other hand up, and I don't know if that means there's no other question or something, but please let us all feel free. Engineer Arthur has said a lot. The conversation, like we said earlier, has to be very interactive. And so where you want clarity, where you want an understanding, you can do all to, you'll be given the opportunity to do that. So Logina is saying again in the chat box that, can you share with us an example you have witnessed before? The problem, how the student found a solution, and how the industry adopted it. If it's not an industry secret, please share with us. Engineer Atta, over to you.
All right, yeah, so this one I will mention, it's not necessarily a student, but a fresh graduate, right? As I indicated, when they are doing national service or graduate trainees, we give them, they're supposed to take on projects, they are supposed to look for projects. So one of them that I think we just shared recently was, we had a blower, and there's a 1 megawatt blower that feeds our biological oxidation plants. So we have a bacteria that we use to treat the gold, right? And they need oxygen. So this blower, based on their properties, their specifications, the inlet air that they take is supposed to be the atmospheric temperature. But when there is an issue with the other blowers that is running with it, it goes into what we call a surge. So when a blower is surging, it's more like it's trying to suck in air, but then it is not able to, the output doesn't go out. And therefore what you get to see is that the air returns, but the returning air is very hot back into the compression side. So what was happening is that the air end of the blower was heating up to the point that the bellows were burning. So the student, the graduate, proposed a solution of installing a temperature sensor. Actually, the blower came, there are temperature sensors all around it, but we had all not thought that we could actually fix a temperature sensor there and integrate it into the system, so that when the temperature is actually exceeding a certain threshold that we know will burn the bellow, we actually stop the system and not continue the surge to continue, so that the bellow will burn and the expansion of the air end will lead to its failure. So we gave it to her. It was a female student. She designed the system. We helped her with all the resources that we need. We purchased the sensor for her, ran the cables and everything, did the integration. She did the programming. We helped her to do the programming. The SCADA integration, the set point was done. And we had 5 blowers, right? So we made her do it for 1. We did a test, it worked. All right. And we replicated it for all the other 5 blowers, right? So this is an example, and I can go on mentioning a lot of them. There is one that we are currently working on, that the same biological oxidation, the air that is actually going into the tank, we would want to use a flow meter. There are flow meters on it, but the valves there are manual. And then someone proposed that, oh, okay, why don't we have an automated valve so that we can have the flow set point set to the valve, so that if maybe the flow reading is going low, for example, then the valve will throttle by itself to ensure that we have the proper amount of air into the tank. That actually, we are not done with it, but another solution that has come even after that to enhance that is to even use the dissolved oxygen sensor in the tank to actually regulate the valve, so that based on the dissolved oxygen levels, the valve will throttle to add more oxygen or air into the tank or not. So all these are projects that are currently running. All right. That I think when done, we would have a lot of benefits for the company. So yes, I can say for what has been working on our side. I don't know and in other companies how they do it. Yeah. Thank you.
Thank you very much, Engineer Atta. I saw one hand up. Kegan, please go ahead.
Yeah, it's Kissman. Congratulations, David. I've been listening. That's a wonderful presentation. Thank you very much. I just wanted to add to what David has mentioned. We give the opportunity to national service and graduate trainees to come up with projects. We call them small wins, it doesn't necessarily have to cost much. It could be $10, $100, whatever, but the effect will be very great. We've got so many in the energy space. We've got so many. A typical one was we have a fridge plant, and where we take up the warm air from underground, take it out, but through some bulk air systems. There's a big ventilation fan, and it extracts heat. You have this refrigerant gas which gets heated. It comes, then the fan extracts the heat from it. Now the bulk air coolers, they are driven by motors. These are huge motors. I think they are about 300 to 400 kilowatt motors. And they are located at the top of the bulk air coolers. Now, once you take the warm air from underground and you bring them out, there is condensation because of the ambience. And it turns into droplets as if it is raining. When you are standing there, you feel as if it is raining. So if this national service or graduate trainee studied the place and saw that the droplets of water that goes up and then comes down, they fall on the motor, that 400 kilowatt motor, and in no time, you have the body of the motor, whether it's car, they were mainly steel, yes, corroding. So in no time, you need to stop the fan, take the motor, and go and do overhauling in the entire motor. And this is a 400 kilowatt. We've got about 3 of them. And the cost of overhauling, all these things. So this lady, it's a lady, she came up with an idea to install just a simple roofing system. But the roof has a hinge on one part of it. So you open it and then swing it to the other side. If you want to do maintenance, then you do maintenance on the motor. Once you finish, you swing it back, close it, and the roof just protects. It's an open sort of roof. Simple, very cheap. He put that roof on top of the 400 kilowatt motor. And since she did that, motors which were overhauled like every quarter, now we're being overhauled like yearly and over a year and that sort of thing. And like David said, do you know how much money she's saving us? This is like the 80-20 principle. Small project, but the output was big. So there are several of these projects that students like your type, they come and they come up with, and the effect is huge. The saving effect is huge. So yes, this is what I just wanted. There are numerous of them. If we want to mention them, we won't finish today. That's so many. I always sit in such presentations, and so I know they do a lot of work. Yeah, thanks.
Okay, thank you so much.
Thanks so much, Engineer Kissman, for the input. I think that is one of our fellows. So thanks for joining in our session, Engineer Kissman.
Sure.
Yeah, thank you. Adding on to the appreciation from Engineer Atta, we are so grateful for your contribution. We'll be ending the session soon, but I personally I don't know whether to call this one a question or a contribution, but Engineer Atta, if you are hearing me, I think one of the problems that we seem to be plagued with as far as the engineering industry is concerned is that we seem to glorify, or if you want, prioritize academic qualifications. I mean, just for purposes of promotion in the industry, other than wanting to solve real world difficulties that we encounter in our various fields. Don't you think that is a problem? Because it's looking like once you want to be promoted, okay, from your position to a higher one, then you should show your certificate. And because of that very reason, it's as if people desire, okay, professionals only desire to go back to school to advance their knowledge, not necessarily to solve a problem or to advance their skill or know-how, okay, in the space where they find themselves, but they just acquire the certificate for promotional purposes. And for that reason, most of them even do present researches as part of their academic requirements. But some of these researches, for all you know, are not even done by them. They just contract people to do the researches for them, most of them plagued in plagiarism and the likes. Don't you think that is also one of the fundamental issues we seem to be governed with? Thank you.
Well, Engineer Swansea, I agree with you completely. But you see, that it's every industry and how it works. I remember when I wanted to do my master's, I was torn between going to do master's in engineering again or doing management. And at the time, I thought that I needed the management more than the engineering at the time. So I did the management. When I was doing the management program, I had other colleagues that I was in class with, and a lot of them were like, "Oh, so now when you are done with your master's, you are going to get promotion, right?" And I'm like, "I'm sorry, no, that's not how it works in my field or in the industry I work in. In the mining environment, you don't get promoted because you have PhD or you have masters. No. All right. It is about your output. It is about what you are delivering to the company. It's about your skill, how you are able to solve problems. You understand? So ideally, you doing the master should be able to have upskilled you to the point that you can be able to solve more problems or lead the teams better, and therefore that should earn you the promotion. Not the other way around, that, okay, you just go get some masters and therefore based on the next appraisal, because you have masters, you're supposed to get a promotion. No, that's not how it's supposed to work. So Engineer Kesman will agree with me that if you look into a lot of the mining companies, you can have a technician or a supervisor that has, say, a PhD, and his boss actually just have a BSc. All right. It is about how much solutions you can bring, what you bring to the table, not about only your degrees. So that is what I can say in the mining environment. I don't know, unfortunately, for the other industries that we have around. Thank you.
Okay, thank you. This will be the last one, and it's coming from Akibeo Stephen Bukatam. Please, if I didn't get the name right, kindly forgive me. But you can find his question in the chat box. He says, from the point of power quality, industries might not want to easily release their data due to penalties or disincentives by the power suppliers. An example in brackets. How do we tackle it?
Well, that is where we say that the collaborative efforts between institutions like GHIE, the industries, bringing them together. Because, Stephen, as you are saying, rightly, yes, but if there has been a lot of other success stories of some institutions that have collaborated very well with the companies to get this data that we are talking about. There are no punitive measures from, say, Gridco, for example, when you are able to release the data, your power quality data to, for example, a student. Myself, and this actually ties within my project that I did in my first degree. I was assessing the impact of voltage instabilities also on drives and motors and all those things. So I had to go and pick almost 6 months worth of daily, hourly recording of voltages from a substation that Gridco and ECG was having. And I needed that data from ECG because they were supplying the mining company I was using as a case study.
Okay, Engineer, please,
it took a lot.
done?
Me were on sheet of papers that had been recorded, and I had to sift through. Yes, so I had to sift through for almost 6 months to ensure. Can you hear me?
Yes,
Hello?
yes, we can. Yes, we can.
So I had to sift through almost 6 months of data, all right, recorded on sheet of paper every hour to put into my system to be able to generate the study that I was doing. So yes, there might be some challenges, but it also depends on how much you push and the support you can have from your institution and also from other institutions like GHI. Thank you.
Thank you so much, Engineer. So Wisdom puts in the chat box that he's understood exactly what you are saying and he expresses his gratitude to you. Ladies and gentlemen, this has been a conversation convened by the youth in engineering under the Ghana Institution of Engineering. We've been having conversations around translating research into industry impact, collaborating with academia and industry. And once again, we are so grateful to all of you for making time to join. Before we end the discussion, we would want to take our closing remarks from Engineer Benedict Atapoku. I am not too sure if he is still in the room, and in his absence, Engineer Patricia will do justice to it. So, closing remarks by Engineer Benedict Atapoku.
Okay, good evening, everybody. Please, this is Engineer Lodina Mens, and I am just taking over from Engineer Patricia. Okay, so I'll just give the closing remark on behalf of the YE President and then also Engineer Patricia. Is that okay, Swansea?
Yes, please go ahead.
Thank you very much. So, YGHIE, we are very happy to have had this webinar, which was led by Engineer David. And per the submission that he gave, he provided practical examples on how research is used for the industry and the areas that we can explore. So he helped us think through our mind what we can actually do when it comes to scaling up research to industrial applications. And we are very grateful for that. He also gave us examples on how it can save the industry a lot of money. And I believe it also brings a lot of personal benefits to these individuals involved as well. He also had Engineer Kigan also given a very wonderful submission. And what is also very important, or what is also worth noting, is the examples that they strategically provided. They all had girls being mentioned in it. And it is exciting to see girls finish their school programs and then also excel in the field of engineering. So actually they finish the school and they go on to work as engineers in the field, which is also very good. And we just hope that God willing next year, when we are looking through our books and archives and we are recording what we've done within the past year, we will have several examples of our students who are on this call and all our engineers who are also on this call collaboratively working together to ensure that our research is being transformed into industrial application. So the engineers on the field are opening their doors, are opening their hands, they are willing to listen, help the students identify problems, and the students too are willing to take up these problems and bring up bold solutions. The problems that they've all mentioned, they mentioned that, oh, it was a small problem, it was a small problem. So it means that maybe they're not looking for very, very, very big solutions. They are looking for solutions that work and solutions that really transform the industry. So we are very grateful, Engineer David, for opening our minds and helping us to see through your lens as well on how we can transform research into industrial applications. So on behalf of YEGHIE, we would like to say a very big thank you to you and all the members of GHIE who have joined the call, our student members, and to you, our moderator as well. Thank you very much.
Thank you so much, Lodina. But please add up if there are any announcements. If there are any announcements, please add that as well.
Okay. No, there are no announcements. But then what maybe I would like to add is that we have this webinar every month. So let's be on the lookout for more exciting, educative webinars. And let's invite our friends, our other colleagues who are on it. I think last year when we had the YE thing, the conference, we had a category for most active institution in participating in our activities, most active individual student member. And some of the data that we use to pick who did what is from these events that YEGHIA organizes. So we just hope that you will be active, both your schools and your president, whatever it is that you are doing. You might find some time and then join and also interact with us. Follow us on all our social media handles and let's get talking. Thank you.
Thank you so much, Engineer Lordina Mens. We started with a prayer, and so it will be appropriate to end this webinar with same. And so we'll call on one of us. I would need one of us to volunteer, just as we did when we began. One of us should volunteer and do us the honors of the closing prayer, please.
Okay, so let's pray. Father, in the name of Jesus, we thank you for a successful meeting. We thank you for bringing us together once again. It's a prayer that whatever that was discussed here, we'll take it and then apply it in our normal lives. We are grateful for the life of the speaker. It's a prayer that you continue to be with him as well. Thank you for being with us throughout the program. This and many other things we ask in Jesus' name. Amen.
Amen. Thank you so much. On this note, a very goodbye to all of us. We'll meet hopefully next month. Bye-bye.